Hello everyone. In this video, we are going to look at some image processing and computer vision basic tasks on a robot here in a scene in CoppeliaSim. So you see here we have this ASTI robot, the biped humanoid robot, and when I run the code, it starts moving toward the vision sensor. And here you can see the result. Now it's not exactly that image, it's that image processed. You see the edge map, you see it's flipped or rotated 180 degrees. You see I added a circle, and you can do all sorts of other things. And I'm gonna show you that. But let's first see the animation or the simulation here. And then we're gonna look at the script. There we go, right? So now if we go, you see that this robot, of course, has its own script for how it is moving, but the vision sensor has its own script for capturing the images, processing, and displaying them. So this is the major thing that we want to look at, this code. And again, this demo does exist in Coppelia. This is one of the demos of Coppelia, but I made it much simpler. And I added a lot of comments to make it readable, and I want to explain that to you. So what do we have? For initialization, we bring the SIM, but this time we are bringing two other APIs. One of them is SIM Vision, the other one is SIM Image Processing, or IM. What's the difference between them? So the SIM Vision one plugin, it is really for fast GPU image processing. So if you want to do fast image processing and you don't want to do it by Lua pixel level, okay, this is the way to go. Now, of course, it has limited capabilities. It has limited number of commands, but this is really good for fast GPU accelerated image processing, okay? And you need to bring it in. Also, if you want to have more advanced commands, more flexible image manipulation commands, like for instance, drawing something on the image, doing some annotation and so on, I'm going to show you. You are going to bring in this SimIM. This is a pixel-based Lua. It's a little bit slower, not a little bit, quite a bit slower, but again, this offers a lot more powerful commands. So let's see what we do. So we bring them in, we get the handle of the vision sensor, and here we have a frame counter, and this one is telling the code that only do the processing every 5 frames. So you can change that number to 3, 2, 1, 10 or something to slow down the process or make it faster. Here, because it's really fast, we're just going to slow it down. So every 5 frames, we're going to do the process here, really. But I just want you to know what these are. And the cleanup function is the one that just resets the vision sensor. Okay, so sim reset vision sensor. Now, let's go ahead and look at the sensing function. So in the sensing function, as you can see, only if the modulus of counter and 5 is equal to 0, which means every 5 frames, you're gonna do the job, otherwise you don't. Okay, so what would you do? Here, you use the command handle vision sensor. You pass to it the sensor handle, and it gives you a trigger. So what does this command do? This command will tell you if the vision sensor has been triggered and if it captured an image or not. And you might say, well, could it be in a situation that it doesn't capture an image? Yes. If you see here your image sensor, let me move this out of the way a little bit. You see that it has this field of views, right? Vertical and horizontal. So as long as the object is within the field of view, it is going to be triggered. And there are also some other threshold for how like bright it should appear, what kind of intensities and so on before it can be triggered. So there are some settings. Okay, if you don't change them, they are going to stay as default, but if you want, you can change them. But the fact that you just put a vision sensor in the scene doesn't mean it is necessarily capturing frames. Okay, so here you say, hey, give me the trigger. If this trigger is a logical variable, if it's 1, that means it captures something. If it's 0, means it didn't. Okay, so what does this code do? As I said, it gives you a trigger, but it does some extra thing. What are the extra thing that it is doing here? First of all, the CoppeliaSim here renders the scene from the viewpoint of the sensor. As we said, if the trigger is done, it creates an RGB image buffer in the memory. So here, this one is not to give you the image, it just creates a buffer image in the memory, and then it runs the vision sensor internal filter chain, if any, and we're going to talk about that. Okay, so if the sensor is triggered, then you're gonna write this message to the status bar using the add log command, and you're simply just gonna say sensor was triggered. Okay, if I go back here and show you the status bar, you can see that this message is shown back to back. Okay, again, if you don't want to show it, that's totally fine. You don't have to, so you can get rid of this message here. So it's totally fine. Okay. Now, let's go and look at the main function, the one that does all the processing. So the thing that you pass to it, the input, is not really the image. It's just the data regarding the vision sensor, like the resolution of it, clipping or projection planes, etc. And this callback function is executed each time the vision sensor is handled. Now, what does handling a vision sensor exactly mean? I added something for you here. Handling a vision sensor means to explicitly processing it. And what does processing it means? It means making it actually capture and analyze the scene. Okay, so basically every time the vision sensor captures a picture and analyzes the scene and captures a picture, this function is called. Now, what does this function do? First of all, it has a bunch of functions using the sim vision that I said this is GPU based, this is fast. Now, if you look at all of these commands that the sim vision is using, these are the commands for copying image, for edge detection, for copying to a buffer, for adding a uniform image to the background, and so on. If you look at these commands, if you look at all of them, the input to them is not, again, the image itself. It's this inData.handle. So what is handle here? This inData handle is the sensor ID of your vision sensor. This is an integer, this is a number. So all you need to pass to these commands is basically the ID of that vision sensor. They go to that vision sensor, they get the image it captured, and then they do their process on it. So these commands do not need to get the image directly, they just need to get the vision sensor handle or ID. Okay, that's one of the things that you can see here. Good, and I mentioned all of that for you over there. Now, what does the first command do? Sim vision sensor image to work image. This command basically copies or creates a copy of the capture image into another image called work image. So many times, you probably, when you did some work with images, if you did ever with MATLAB or anything, you bring in the original image and now you want to make copies of that where some kind of operation is done on it, and you don't want to modify the original image that you read in. This is what it is here. The sensor image is that original image you captured. Work image is the copy that you want to modify. So here you make a copy of the sensor image into another image called the work image. This is the one you can do whatever you want to it. Okay, good. So first you make a working copy of that. Now what? Now on this work image, you apply the edge detector. So the threshold here is 0.2. Now this is a very simple command. You just apply a threshold to see how to determine how sensitive it is to the edges. So if you change this number, the amount of the edges that you would detect would be different. So for instance, right now is 0.2. Let me show you. With 0.2, you see the kind of edges that you're getting, right? You see a lot of edges here. You see lots of small pixels and so on. Now, if I go back and modify this threshold here, right? So instead of 0.2, I say what? I say, let's say 0.7, okay? So if I do that 0.7 and run it again, let's see the difference. You see? Now, a lot of extra noisy data that you got, all of those small intensities that you got, they are all gone. Your edge map is not as busy and crowded as it was. Okay, so smaller number means more sensitive, bigger number means less sensitive, and you can clearly see that over here. Okay, so you do that, then what? Now, the next thing you do, you swap the work image with buffer. What is this? What is a buffer here? Every vision sensor that you create in a scene and you manage it by the sim vision, it has a few specific image buffers, like they are called buffer 1, buffer 2, and so on, okay? So each vision sensor, they have specific GPU residents, or the ones that stay in the GPU buffers for images. So now you're saying what? You're saying temporarily store the work image into the buffer 1 of the GPU for this vision sensor. Then what? Now you go to that work image and you say uniform image 2. What does this one do? Here, you go to that work image, whatever it was in it, which was the edge map, you overwrite it here by a uniform image. What kind of uniform image is that? It's an image with uniform color of 0.5, 0.25, and 0 RGB values. So you create a uniform color background image, okay? And then you add that to your, you bring the buffer image and now add it to the work image. So what did you do? You move the edge map to the buffer. You basically created a uniform image in the work image, and then you brought that buffer, which was the edge map, and you added it to the uniform background, right? So this is adding the edge map to the uniform background image just created, right? So now the image that you have should be a background uniform and an edge map, and that's exactly what it is here. You can see that clearly. Look, your background is uniform color, and then you have this white edge map added to it, okay? So that's why you, instead of the actual image, you see the edge map over a uniform thing. It's because of those commands. Now, let's go back here. So we did this part, right? Then what? Now you say, now this work image, which is the uniform plus edge map, go ahead and write it back to the sensor image. Why? Because this window that you see here is actually showing the sensor image. It's not showing your buffer image. It's not showing your work image. This is the sensor image. We got it. We took it inside. We modified it. We write it back to the sensor image so it can be displayed. Right? So we got that done. Now, the rest of these commands are the commands that now you can do with the SIM with the pixel-wise operations that are CPU-based and a little bit slower. So what will you do here? Look, first you read from the vision sensor with that sensor handle, you read the image handle, okay? You read the image handle, then what? Here you define a center of the image. You say image int data resolution number 1, resolution number 2 divided by 2. Remember, I said int data has the resolution of the image, and that means the height and the width of the image. So you're dividing it by 2 to get the center of the image. You define a radius, which is exactly where? It is the width plus height divided by 8. That's the radius of the circle you want to draw. This is the center of the circle you want to draw. Now you use the circle command that is inside the SIM. You say, hey, go to the image handle. I'll give you the center. I give you the radius with the color black and with the pixel thickness of 4 pixels, with the line width of 4 pixels. Overwrite, or not overwrite, add to that image what? Add to it a black circle, and that is exactly, you saw what we have, right? You see, this is the black circle, 4 pixels wide at the center with a radius of what? With the radius of width plus height divided by 8. Okay? So this is one of the things you do now with the circle command. The next thing you do here is you say, hey, I want now that you go and write this image handle modified to that sensor, and then go ahead and destroy the image handle. Okay? So you see that here, the IM command is working with an image handle instead of what? Instead of directly working with the vision sensor handle, they are working with image handle. So they get the image handle, they do all the operations on it, in this case just adding a circle, and then here we just cleaned up that temporary image handle. Then what? This is another thing that you do. Here you get the vision sensor image, okay? You get the vision sensor image, and again you pass it the vision sensor handle, and this one, this time, this is actually an image. This command actually gives you the image as a matrix. It's not an image handle. Look at the difference between this command and this one. Read from vision sensor. You give it the vision sensor handle, it gives you an image handle. This command, get vision sensor image, you give it the vision sensor handle, it gives you an actual matrix. So this is a third way to work with images. So okay, I got an image. Now what do? I use the command sim transfer image. This one is not even under SIM. Okay, this is not under SIM. This one is directly under SIM because SIM can handle a matrix and this guy is a matrix. I want to apply a geometric transform on it, transformation. I pass it the image, I give it the image size, and I give it an operation code. Now, what does this for mean? It means rotate the image 180 degrees. Okay, if I don't do this line, if I comment out this line, the image that you sign the sensor is not going to be upside down. Look, because right now, you see this one is rotated 180 degrees. So if I comment out this line, look, then you're going to see the image normal without any upside down. Look here. There we go. Right? So you can perform any operation on it or not perform any operation on it if you like. Right now, the operation done was basically to flip that 180 degrees. But if you want, you can flip it vertically, horizontally, you can rotate it, you can transpose it, you can inverse transpose it, and so on. So right now, we pick that, okay? And I uncomment this. So fine. Now that I rotated it 180 degrees, what do? Then last thing that I do to it before sending it out and showing, what we call a transform buffer. What is this? Here you are converting your channels from RGB to BGR. Why BGR? Because if you know OpenCV and Python, they are working on color images where the channels that they read and process are blue, green, red, not red, green, blue. So that is basically what this one does. You pass to it the image, you say, hey, I want it to go from uint8 RGB to uint8 BGR. I don't want your pixel to be multiplied by anything or offset, which means adding any constant to them. Just go from RGB to BGR. And once this transformation is done, now go ahead and set vision sensor image. So now that the image is modified, now go to that vision sensor handle, put this image as the sensor image so it can be shown here, right? And let me run this for you. There we go. Look. So you see, this is what you have. And by the way, let me go back a second. Let me show you something. So if I don't do this line, what's going to happen? Let's comment it out, see what's going to happen. So I don't change RGB to BGR. Look what happens. It is brown. Do you see why? Because the color that I gave it here for that uniform image, let me show you, it is this guy. Half red and a quarter green, which is exactly brown. But when you do BGR, now this first one is going to be B, so half blue and 0.25 green and 0 red, which is going to be that kind of navy blue that you saw. So this one here is basically changing what? Changing that color here from brown to what? To blue. So let me add that here. Changes the background color from brown to blue. And here is uniform color image, here brown. Right? So basically, these are some of the operations that is done in this code, and you can see them: creating uniform image, creating edge map, flipping the image, adding a circle to it, and so on and so forth, right? And there are a lot more commands under image processing. So this is just, I would say, our first demo on performing image processing in CoppeliaSim. I'll try to make further videos and show you how to perform more advanced tasks that are more kind of computer vision than image processing. So thank you so much for your attention. I'll see you in the next video.